Problem 39, page 556. Use the diagram below. Each triangle in the diagram is a 45, 45, 90 degrees triangle. At stage 0, the legs of the triangle are each 1 unit long. And then you have stage 1, stage 2, stage 3, stage 4, right? So let's start with the given triangle. I have a 1 by 1 right triangle. This is 1, this is 1, right? That's a 90 degree angle. You want it this is stage 1. Stage 2, I have the same triangle, but on each one of its sides, I'm constructing another triangle that will have 45, 45, 90 degree angles. Basically, its sides are congruent, right? And I should use different colors for this. I know this one is congruent to that one, this one congruent to this one, and they're actually congruent to each other. This is stage 2. On the next stage, I will have the initial triangle, right, as this one. Then on this initial triangle, I have the stage 2 triangles, and then on each one of this, I will construct 2 other small triangles, right? And I will color them. Let's see. I have yellow, right? Then I have purple, and then the initial one, let's leave it 1. And the problem is asking us to determine what is the length, find the exact length of the legs of the triangles that are added at each stage. Leave radicals in the denominators of fractions. So we don't have to change our fractions, and we can leave the radicals as a denominator, right? So let's start with observing what's happening from stage 1 to stage 2, and then I have stage 3, stage 4, and that's about it, right? Stage 1. How big are your lengths? Your lengths are how big? 1 each, right? If I'm going from stage 1 to stage 2, how big will be the sides of your purple triangles in here? How can I find that? What's happening? I know this side here is 1, that's also 1. If the sides of my triangles will have a length of A, right? This will also be A. What is the relation between your side A and this side here, which is absolutely your hypotenuse for this new triangle? What is the relation? Hypotenuse and one side in a 45, 45, 90 degrees triangle. Do you guys remember that? If I have a triangle, a right triangle, right, and this is a 90 degree, I know this one is X, this one is X. Basically I have my 45, 45, right? How big is going to be the hypotenuse? Look, how big is your hypotenuse in a 45, 45, knowing that one leg is X? X, what? square root 2, right? So going back to my triangles here, I can say that, you know, for this small right triangle that has a side of A and the other side A and the other one 1, actually that hypotenuse 1 is equal to A square root 2. Okay, we're on the stage 2. Knowing that, I can find my A, my side. My side is actually equal to what? 1 divided by 1. By square root 2. Now, this is the side for the second stage. If I'm moving on to the third stage, in the third stage, I have to find this side, right? I know that's going to be B, this is also going to be B, and I know that the length of this side here is A, but my A was what? 1 over square root 2. So I know that for this stage, the length of your side, B, will be, in what relation? You know what, let's start with stating what relation is between B, the side B in this yellow triangle, and your hypotenuse A, right? A will equal what? B multiplied by, it's the same, 45, 45, 90 degrees triangle. What is the relation between B and A? How can I find A knowing B? A would be B multiplied by what, Anthony? Karen? A will be B times 1 in this triangle. It's a 45, 45, 90 degrees. A will be how big? A is the side, cannot be 180. A is the side. How can you find that side? Knowing that this is a 45, 45. So this is a triangle where I know this one is 45, this one is 45 degrees, right? And I know one side is B. How big is this side? B multiplied by what? Square root 2, guys. Why so hard? I don't get it. We just did it in stage 2. B square root 2. Alright? Which means your side B will be found by dividing A by square root 2. But your A is 1 over square root 2 divided by square root 2 will actually equal 1 over 1. 1 over 2. Is that right? So that's your B, if you want. Stage 3, your side will be 1 over 2. Now if I have to go for the next side, for the next stage, if I have stage 4, what will be the length of that side? Think about it. I will also have another triangle that's constructed here. Let's say supposedly my side is C. This was B right here. So what is the relation between C and B, knowing that I have 45 degrees here? B equals what? C multiplied by square root 2. Which means your side for the stage 4 is nothing else but B divided by square root 2, but my B was 1/2. So it'll be 1/2 over square root 2, which equals 1 over 2 square root 2. Right? That's your C. The side the side of the small triangles in stage 4. Is that so? Or the problem looks a little bit different? The problem is different actually. I'm looking now. Because problem number 31. Page 555. Find the values of R, S, T, U, V, and W for the following figure, right? And you start with a 90-degree triangle that has congruent sides of 1 unit length. Then on the top of this triangle, you're constructing another right triangle that will have the initial triangle's hypotenuse and one of its legs right here of the same length of 1, right? And that's my next triangle. Then from this one you will construct another right triangle that will also have a length of 1 for this time, right? Then from this one you will have another right triangle that will also have a length of 1. Then from this one you will make another right triangle by just constructing a side here of 1 unit in length, right? And then the final one, another triangle by having another side of length 1, and each one of the sides you have to find how long are, right? So this is R, S, T, U, V, and W. Well, if you go with the first triangle here, how big is R from the first triangle? Or what is the relation between R squared and the other two sides? R is how big? R squared is what? 1 squared plus 1 squared, which equals 2. That means your R is how big? How big is my R? Square root 2. Now I'm going with the next triangle. In this one right here with one side R, one 1, and one S. Well, S is your hypotenuse. S squared will equal R squared plus 1 squared. And that equals 1. Well, R squared we know was 2. So it'll be 2 plus 1, which is 3. That means your S will be square root 3. I'm going with the next one. In this triangle, light blue, right, with S, 1, and T as sides. T is my hypotenuse. T squared will equal the sum of the squares of the other two sides. S squared plus 1 squared, which equals 3 plus 1 equals 4. Which means your T will be square root 4. So that's 2. Next triangle, dark green one, right? T1 and U. In that triangle, by Pythagoras theorem, U squared is nothing else but T squared plus 1 squared, and that equals 4 plus 1, which is 5. Your U is nothing else but square root 5. Next triangle, the purple sides, U1 and V. Well, V squared, which is hypotenuse squared, right, equals U squared plus 1 squared, and that equals 5 plus 1, which is 6. Your U will be square root 6. I mean your V, I'm sorry. V is square root 6. And let's put a box on this U also. Final one, W, right? Well, in this gray triangle, I have sides V1 and W. My W squared equals V squared plus 1 squared, which equals 6 plus 1, and that would be 7. My W would be square root 7. And this is it.